My name is Baswaraj. I'm currently the CEO of RV Skills, the premier institution primarily focusing on building necessary skills on the emerging technologies and more so on the VLSI design space. Um, I'll share a little more details about RV Skills a little later, but getting back to my introduction, so I've spent about 31 years in the industry. I started my career way back in '94 in the telecom industry, being more on the business and strategic product development. And over the period, I've kind of worked in multiple organizations, mostly like start with engaging with the company when they are in the early stage of startup, and work with them until we kind of scale or take them to IPO. So way back in 2013, I quit the corporate world, and then I focused in terms of building um, a more interesting opportunity for my career where I wanted to kind of work with the startups to advise them, raise capital for them. So henceforth, post that, I've been kind of involved in quite a few startups, more in the advisory role, also as a co-founder, and I've started a couple of my own ventures, not so more so on semiconductor, but on renewable energy, educational, edtech, and in other areas. But my contribution to semiconductor started with me being on the board of one of the fabulous design company before I joined RV Skills in 2023, where I've kind of taken the leadership role to kind of see how we can build the organization from where it is, or the kind of history or legacy it had created over the last 19 years. So I kind of taken up the mantle to see how we can probably expand this or build this much more deeper and wider. So that's a little bit about my background. Primarily, I've done my engineering in telecom and also done my MBA from US University. So that's a little quick background about myself. Now, getting back uh, to the session for today. Like I said, I think fundamentally you probably need to question whether there is going to be an industry that probably will be exciting for each of you, right? So let's focus on those points and try to see whether we can answer some of these questions before we kind of get into some of the technicalities of what each of these domains that you probably have aspiration to join um, is going to be exciting for you, right? So, like I said, my agenda for today, I will cover about why VLSI matters and what is happening right now in the industry, the impact this industry has. I'll also kind of share some industry landscape in terms of what is happening in the overall ecosystem, and more so focused on what is the kind of opportunity that we have within India as well. I'll probably bring in some kind of a reference and cross check in terms of what's happening in the other parts of the world as well, because it is important to kind of set the context in terms of why we see India finds this semiconductor as a great opportunity and why each of your career that you plan to build in this core industry will have relevance. Then, of course, I will cover some of the career pathways, um, some on the back end, some on the front end, and also on the analog and other aspects of VLSI design workflow. Then I'll talk about it very quickly in terms of what's happening in terms of um, the trends and challenges that is there out there, and what is that you should specifically focus in terms of ensuring that you are going to be in the middle of all this exciting transition that is happening, and what is that you should probably do independent of whether you plan to pursue this industry as a process of skill development or as an employee or as even some of them might have aspiration to become a startup as well, right? What could probably be exciting for each of you to be doing that. We will try to take the Q&A at the last point, but just in case we run out of time, I will leave the email ID. Feel free to send out your questions over the email. I will ensure that either myself or my team will respond to each of those questions, because we have a very small, rather small window for us to cover a huge topic. So I thought, like, it is going to be important to kind of cover some of the key aspects before we kind of end the session for today, right? Does it sound fine? Okay, fantastic. So why should VLSI matter, right? Why is it so relevant today, or was it actually relevant for a long time? Why is it so much important for us today, for India, for the rest of the world? What are the kind of new innovation that is coming in? I think these are these are questions I'm sure most of you must be familiar because all of you are using smartphones today, right? The reason why it is called smartphones is because of the kind of intelligence and design that has gone into your processor that is sitting inside, right? Now, I don't know what is the age bracket of each of you are attending, but trust me, I think if I take the average as 25, if you go back about 25 years, I think the industry looked a lot more different than what it is today, right? Most of the processing devices that we could use at that point of a time were your personal computers or servers or other desktops that were probably like huge machines with a bigger processor and very minimal number of transistors per square centimeter. And the two companies that probably were very familiarly known at that point of a time was either Intel or AMD. And I think approximately they had close to about 150 to 200 million devices, all put together within terms of laptop, computers, and servers and other things as well. But today, when you look in terms of what is the current dynamics in terms of the smartphones that each of you are using, which is much more efficient, much more complex, and it is more powerful than what the computers were those days. And you look in terms of today's volume, as far as I see the current trend, they're close to about 5.5 billion of those smartphones used across the globe of population of 8.5 billion, right? Now, interestingly, the percentage of processor used in the smartphones by either Intel or AMD is zero. And if you look in terms of the overall ecosystem for these 4.5 or 5.5 million smartphones, it is quite different and drastically different compared to what it was then during the Intel and AMD days. Today, I think it is no more one company dealing with everything. Like Intel used to do everything from design to fabrication to packaging and everything, and then finally the processor was given to Dell or Lenovo or at that point of an IBM or whichever the company which needed those, they could probably give the complete package chip to them or the processor to them, and it is for them to kind of put them into the device that they were manufacturing, whether it is laptops, desktops, or servers, and then the end user would start using it. Today, it is not more the same, no more the same, right? Qualcomm designs the IP for your processor. Of course, they use the ARM IP, most of it, and they integrate the other peripherals together. And the final design, which is ready to tape out. Tape out is the term that we use when the design is ready to be put into the fabrication unit. They gave it to companies like TSMC, which is the largest fabrication unit globally based out of Taiwan. And they kind of burn it on the silicon or the wafer, and then that gets to companies who does the packaging. And once the processor is ready, then it goes to companies to put everything integrated into a mobile phone, and then you put a logo of any of the smart companies, whether it is Apple or it is Google or it could be Micromax or OnePlus or whatever, right? Any of these companies, and then they get marketed, and then it lands up in your hand. Now, the reason why I'm trying to lay out this is this democratization of innovation or a collaborative approach is what is transforming the scale and volume of utilization of the resource and the and the technology. I see this as a fundamentally important change or the dynamics of how it is changed, which empowers each of you also to become an entrepreneur. All you need is an idea which is compelling and interesting, which you could probably work with a lot of these ecosystem players to build that product finally, which is commercially ready, and then you can launch them, right? It is possible. That's a reality that you can certainly attempt to in the current context. It might have not been possible about 2 or 3 decades, but today I think that is essentially possible, and which is why Gartner predicts that we will probably have close to about 30 billion connected devices, which essentially means that each of you will be carrying about 4 or 5 devices on you. I think today most of us do already about 2 or 3, but I think it's not too far for us to see 4 to 5 devices on us, because that's the kind of volume and scale that you will see going forward, right? Now, getting back to my question, why VLSI matters, I think the answer you must have kind of understood from the context of what I gave the background today, because the processor that sits in your phone, it has limitation in terms of the real estate, which is the space. It has limitation in terms of power, but it has enormous need of processing. And that's like in a way the challenge in terms of putting billions of transistors into a small space, and hence the VLSI matters, right? So essentially, what VLSI means is basically trying to integrate a large volume of transistors into a chip, right? That's the whole simple English explanation of what VLSI means, right? Now, the current applications that you must have been familiar or you would have probably been exposed to is the smartphone that I talked about, but there are quite a few variety of other applications where we can see a smaller chip with a complex design in it working on like your smartphones or your medical devices or even defense that will have a very mission critical importance or space, right? All of these are like potential applications, and impact of that is quite profound. Now, today, I think it becomes more so important because of our adaptation or our inclination towards that. Hence, the potential opportunity that is going to be available for us is going to be enormous. I think it is now at the juncture. I think I remember in one of the conversation when I attended Semicon recently, one of the a key member from the industry mentioned about saying that today I think we are in the era where it was analogy to that is very similar to what it was on the early days of internet. When the internet opened up about 30 years ago, where it was all dial-up and it would take like forever to connect, and the speed at which speed was terribly bad. It is, I think, those days that we see in terms of electronics or semiconductor utilization. So think about what is going to be the potential of these evolving into something more profound in the next 25, 30 years. Right? It's going to be huge. So that's one clear validation for you to kind of become aware what is going to be the future and why it is going to be even more relevant, because most of these whatever our current utilization of these hardware is also going to change, because the chemical structure or the physical structure of these hardware is also going to continue to change. I mean, recently I saw that the evolution of phones that we currently hold in our hand is not going to be the same anymore. You would probably have those chips embedded in your fingertips or behind your ears, and you don't need to hold your hand to reach out to your ear and the mouthpiece to speak. It can naturally happen. Even to the extent some of the devices are going to be embedded in your brain, where you don't have to speak out. Automatically, your thoughts can probably be relaying your conversation either to the person that you want to speak or to the system, and that's is becoming reality very soon. So it is not going to be any more relevant in terms of understanding the complexity of the physical space, but the whole chemical structure or physical structure of these devices is set to transform. Hence, the potential for you to kind of become part of this industry becomes more and more relevant, right? Now, I've just listed a few of these evolutions that we will all probably come across. Today we are on 5G. Of course, we don't use extensively all the 5G implementation is not across the board. I mean, I would be more concerned in terms of the applications around 5G technology. So I don't see much of those implemented, but I think it is not going to be too far away for us to see a lot of those adoption in terms of application on 5G. But people are already working on technologies approval system definition for 6G already, right? Now, the application that I was talking about on 5G, where it probably empowers is the smart meters with the electricity meters or your water meters or your cars that are connected on 5G, so that it has a better access of how you can track or commute and things like that using the 5G as a technology layer and the physical layer. Where of course the underlying technology will be more relevant to the in-house processing of the automobile industry, but I'm talking in terms of the connectivity, so that you have a more clear connectivity on the cloud as well. I think defense systems, I put it there more specifically, so even though I could have probably added other things, but because we've seen the kind of enormous possibilities because of the strategic defense warfare that we saw during the recent months in between countries like India and Pakistan or Israel and other countries in the Middle East. I think it's no doubt in terms of the strategic importance of these segments also playing out, and what semiconductor could do or AI could do, right? So I don't think there would be any particular application or domain that you probably can be set aside without having to use semiconductor. So the point again goes back to you to let you know the kind of potential that this industry has. And trust me, I've not even covered the other aspect of it, which will accelerate the whole consumption. For example, the invent of the whole impact of AI or quantum compute, right? How each of these technologies will probably accelerate the demand and need and opportunities for semiconductor. I'm not even covering that. Of course, you need multiple sessions to cover those topics. But I'm just saying, within even the current context, the importance of these devices and the industries are going to be enormous. Now, the uh, the reason, again, like I said, it's power. It's going to be more because of the kind of the miniaturization of the whole devices and the smart activities that you need to put in is where the whole complexities of this VLSI design will evolve and opportunities that probably will bring in for you for your career. But I think it is important also to kind of understand, even though I would probably love to talk about opportunities and the scope, but it is important for you to understand the last point that where it has an high barrier to entry. So what I mean by that is it is not going to be easy for everybody to become a design engineer, right? Again, I'm not trying to induce some amount of concern or fear, but it is important to understand what the expectation of this industry is, and your commitment towards that is going to be very profound, right? Now, the reason I said it is not going to be easy for anybody and everybody to be a design engineer is because primarily the commitment to the skill development is going to be very important. Um, so I'll just give you the numbers so that you understand the context of why this becomes very relevant for us. On a yearly basis, we see close to about 18 to 19 lakh engineers passing out from various streams of engineering across India every year. Now, of course, for me, fundamentally, I believe, uh, I mean, I keep asking this question whenever I go to any college university saying that how many of that 18 lakh engineers are actually going to be truly engineers, right? Which is quite hurtful for me personally because engineers spending 4 years and not doing engineering job itself is a big concern. But anyway, I think that's not let's not get into those dilemma of questioning the ethical practices of that. But for me, I think it is very important to understand the scale. That's the reason I'm giving you this number for you. Why it is important to commit and stay on that track. Now, out of the 18 lakh, not all of them can become a design engineer because the complexity of the subject demands you to have a very strong analytical or mathematical skill set so that you understand the whole complexity that goes in terms of designing a chip, right? Now, what do I mean by that? I think let me set the context so that you understand why it is certainly complex and it needs a very good skill sets on engineering or STEM, especially is. See, way back in 1970, when the initial processor chips were designed, it had probably over thousands of transistors in it. Today, when you look at Apple's best of the chips today, for example, Apple launched the iPhone 17 just a couple of days back. The the processor that are sitting inside those iPhone 17 could have close to about 20 to 30 billion transistors. Now, think about the reason why I said complex is you need to put those 20 or 30 billion transistors within the available real estate that is going to be fixed for you, right? Not only there is a complexity of this transistors, so many transistors putting into a chip, it has to work with an optimal power consumption. It can't consume the whole power that a data center could consume, right? Or it can't take up the power of what your house is consuming today. It has a very limited scope of how much of power it can consume, but it has to do phenomenally great number of services, whether it is the smart camera that you use or processing you do in terms of querying details or talking to somebody else. It could be any number of things all together or one at a time. That complexity design is where the challenge in terms of how your career is going to be folded. Now, even though it is complex, trust me, I think I told you I'm not going to scare you, but I think it is important that you understand it is not something difficult for anybody to become. Uh, it's not difficult for you to kind of orient your skills around that. What is important is, like I said earlier, also partly is you need to have a certain discipline and a commitment. And practicing and learning this in an environment that probably empowers you, it is not going to be difficult to become a design engineer. So I think that is very important for you to understand. Any skill, for example, the whole definition of skill is comes with practice. And even the skill of being a design engineer demands you to have that kind of commitment where you can practice continuously in a certain environment that probably will empower you to become aware of how the design happens. And that is where you will become at least reasonable enough to become a design engineer to start your career. But if you ask me whether what is the actual commitment in terms of a person to build a complete skills to become a reasonably good design engineer, my estimate is needs about 3 years, right? So, which is why we are also working with some other colleges where we can start working with the student right from the third semester onwards. But unfortunately, the colleges have their own curriculum, they have their own commitments, and they have their own priorities. So it is not something that we see a lot of them committing to integrate this as a very core part of their overall curriculum. But I don't see this as going to be a kind of a situation going forward, right? Because there are going to be so many industries coming up, and all of them requiring design engineers or manufacturing engineers or quality engineers or application engineers in the semiconductor. Things will have to change across the academic institution as well. So anyway, with that thought, I just want to let you know that the future for VLSI is certainly exciting, and each of you can build your career in this segment. Doesn't matter what you aspire to become, it is possible. All you need to do is to have a certain commitment and discipline and the right environment to learn the skills. Now, I'm sure most of you must be keeping track of what's happening in the industry, what is the kind of investment. Now, I'll take a very small detour in terms of making a very important relevance on why this is important for you to understand, right? I think I started with a question saying that is the industry relevant, whether you have a career. So fundamentally, when I look from a business point of view, the way I look in terms of the analogy is, our business is investing in this segment. Is the government invested into this segment? What is the importance of this industry for the government or for industry? That gives you a very good analogy to say whether it's going to be long haul, whether there is going to be a substantial value, whether your careers can be built around this. So this is how you kind of probably do the analysis. And being a strategic analyst, rather strategic advisor over the last 20 odd years, that is my job in terms of looking at data points and trying to connect that and see what is the future looks like and how important. That's like where my strengths are. So which is why I thought it's important to find that for you to also understand the context in terms of why do you think there is an opportunity that exists and why this is going to be the right career opportunity for you, right? So India realized very late about the importance of having to commit on the semiconductor industry. Now, if you were to look in terms of over 10, 15 years back, the number of the amount of money that government used to pay or the economy used to pay for importing mobile phones is so huge that it actually exceeds even your import of crude oil. Now, that kind of money going out from a country is not a good healthy sign. More so if you were to look in terms of the consumption increasing. So spending about $500 billion on just importing mobile phones or other electronic goods is not good for economy, right? That's when the government realized the importance and the risk of I have to fix this, and also being more so in terms of becoming self-reliable and competent like internally, and also kind of build the aspirations around that. So this has been something that was cooking for a long time, and I work with quite a few bureaucrats in the policy decision for the Indian government way back in 2015, and I kind of realized the importance this government is going to put in on this, because it was very clearly visible for us that if you don't fix that issue, it could probably collapse into a bigger nightmare for the country and for all of us to deal with. Now, that's being the trigger, and today I think the amount of money that government has invested into this whole industry is phenomenal. When I went back and looked in terms of what they've done in other industries, I couldn't find anything parallel to that. As of today, Government of India has invested close to about 2 lakh crores, allowing companies to come and set up their manufacturing around semiconductor. See, India was very good on design space. Of course, we were offering more as a services to a lot of large companies, but that was certainly a good thing. At least you had the talent, you had the right kind of resource. So for us to kind of look in terms of using those resources to build other things was reasonably possible. But we had absolutely nothing on the manufacturing side. So for us to attract a lot of those industries, you have to incentivize. So trust me, I think the way the Indian government is putting money into this is huge. I'll give you an example. If suppose somebody wants to set up any semiconductor factory on a large scale, for example, a fabrication unit, which is a huge investment, capital investment, in the tune of anywhere about $10 billion, which is almost about, in the today's dollar rate, is almost about 90,000 crores. It is not going to be possible for some industry to put up that kind of investment and figure out how to build a business. So to attract the business, government said that they're going to put, central government would put about 50% of that investment, and the state governments, which is honoring that contract, they will put about 25%. So essentially, out of the 1 lakh crore, 75,000 crores was invested from the government, sorry. The industry had to put only 25,000 crores. And that kind of the scheme was exciting enough, and large companies like Tata, Keynes, and others have started putting up enormous. Of course, it's not easy for anybody to get the contract approved by the government of India, because they look through things much more in detail, and they look for a commitment and establishment and things like that. But anybody who could prove that metal, I think it is the fantastic business opportunity for them to invest at this point of a time. So there has been amazing kind of progress on that side. In fact, when I was there in Semicon a month back in Delhi, we saw a lot of in-house design chips turned out as well, or rather taped out. So I think all of these are very, very interesting milestone for all of us, and to see the future, the kind of job opportunities that I see, this is all going to open up. The estimate informally when I was talking to the team there, overall they are expecting almost about 1 lakh engineers across design, manufacturing, quality, product, and other development. Close to about 1 lakh of them will probably be hired in the next 2 to 3 years. I mean, that's just the beginning. And again, I'm not talking about Indian talent needed by the rest of the world. In fact, that's a bigger opportunity. And in fact, the government is pitching, saying that can Indian talent be the global? I mean, they're even pitching that India can become a global semiconductor talent hub. So there are a lot of, excuse me, there are a lot of investment that the government is making, and expecting the institutions to prepare the talent that is going to be globally worthwhile. So all net, what I'm saying is there is fantastic opportunities, there are fantastic investment that is coming up, and this is going to be something that I see is going to be a fantastic career opportunity for each of you for the next 25 years. Now, even though I don't mean to arm what is the contribution from software industry over the last 25 years, but I think today, we are at the crossroads where software jobs are going to become diluted because of the advent of AI. You must have seen the news announcement from companies like Google or even Infosys here in Bangalore. They're going to be investing heavily on AI, which means that they're going to cut down on the resource cost. So that's the business justification, how they can invest on new technologies, because they'll have to find alternate way to cut the other things. So when they're investing in AI, that means that they will probably have to let go a lot of resource, right? Now, what happens to the future of software? Honestly, I don't know. But certainly there is going to be a risk. So I just thought it is important for all of you to become aware of it and accordingly plan your career. Now, Taiwan is a very interesting country. I mean, I've traveled there multiple times, and I've seen the kind of amazing things that happens in Taiwan. So I'll just leave with 2 points, because it requires a lot more time to talk about what is happening in Taiwan in detail. But I want to leave 2 points with you so that you understand why, for me, it fascinates Taiwan, and why we should probably look at a lot of learning from Taiwan for us as well. One is the company that probably would manufacture almost all the silicon that you must be using today, whether it's your smartphones or your smart key or a smartwatch or anything that is got electronics in it. It's more likely they must have been fabricated in TSMC. TSMC is one of the largest fabrication company, and they're based out of Taiwan. In fact, I would urge you, each of you, to go back and look at the history of formation of TSMC, and you'll be fascinated in terms of a country like Taiwan could dare to build a company like that. And today they are global number one company. producing almost about 68% of silicon for the world, right? It's quite amazing. I would urge each of you to read the whole history of formation of TSMC and what is happening there. It's just like unbelievable. That's one. Second, I think their commitment of building the right skill right from early days is quite amazing. I mean, I visited a lot of universities there in Taiwan, and I was amazed to see the kind of investment they've made in each and every institution, whether it's government run, privately run, or quasi-government and quasi-private. They've made an enormous amount of investment in building the right infrastructure for semiconductor, and they train the whole student right from first year onwards till they have complete the course, where they become so efficient from day one of their exit from college, they could actually work in the production environment. That's the kind of experiential learning they go through, and it's just phenomenal. And there is a very strong demand to ensure that they go through that rigor, right? And for me, I think that's like where I see we will probably be able to transform our engineers to become more innovative and entrepreneurial than just looking at chasing jobs which are offered to services industry. I mean, that's where personally I'm trying to work in terms of how we can create something similar for us in India. Now, lastly, I want to touch upon something that is happening in US. So US has actually been way ahead in terms of innovation, especially if you look at what we do today in terms of semiconductor. A lot of those things came from US, but they're losing the edge because either Taiwan is far ahead or China is also growing quite aggressively. The number of patents they've been filing is enormous. If you look at the last 10 years of patent filing, you'll find that China is probably leading in the last 10 years. So US is actually drifting down. So that has become a big risk now, especially knowing the fact that what the semiconductor or hardware industry can mean to them and the threat that it could have. I mean, I don't know if any of you are familiar. Today, the war is not going to be anymore using guns and cannons and aircrafts. The war for tomorrow is more on cyber attacks or electronics. What Israel did with the pages in Middle East is unbelievable. Think about it. There are going to be much more consequences that you could probably be dealing with if the big-fledged war breaks out because the penetration of all these semiconductor. Now, having control on that manufacturing and also design is something that each country have come to realize. Otherwise, countries like US also shut down a large petrochemical company, global company. They shut down for 1 week without giving access to their data center, right? A lot of these, and during COVID, I think that when China shut down all the automotive chips exports, the whole global industries for automotive were completely taken a beating. Something that cost about a couple of cents, the same chip was available on demand for about $30. It's 1,000 times more than what it used to cost. Think about the overall cost, the impact of the overall pricing and the economy, right? So a lot of these things over the last 5 years has given significant importance for semiconductor reliance on their own country. So US is no different. They're in fact spending almost 10 times what India is spending now to bring back all the industries there. But what is interesting to know is that they don't have talent. And they can't build the talent on their own. So I see a tremendous potential for a lot of semiconductor engineers getting absorbed into US if you have aspiration to go back and work or pursue your careers there in the US as well. I mean, it's not just US. In fact, the same across Europe, same across Japan. So there is going to be tremendous. And UAE, in fact, I heard they are investing heavily. In fact, they're building one of the largest AI data center compared to anywhere in the world, right? They're investing close to about $100 billion to build a largest AI data center. So if you go back and look at why and what is going to happen, there's no doubt in the terms of importance of having a lot of industry around hardware in Middle East as well. So globally, I see tremendous opportunity, and there's going to be enough and more need of talent across the world, right? I mean, I just put the snapshot in terms of what investment India has done just for you to kind of look at it. Again, net, what I'm trying to make all of you aware is that the future for any economy to become or committed is going to be on the hardware. So you probably need to be very clearly aware of this and accordingly build your career aspirations around that. But again, let me also be very clear saying that it is important that you commit and make a very serious disciplined commitment to build the right skill sets so that you can become part of this industry. Because if you start your career now, I think there are going to be potential opportunities that you will probably be ready when the industry starts opening up. When the rest of the other industry will probably start tapering down, this industry will start seeing peaking and growing much more. And given the fact, even with utilization of AI in the overall flow, still I see tremendous opportunities that will be available for either design engineers or even manufacturing engineers. Now, I'm going to just quickly rush through in terms of different domain that probably you can pursue your career. I'm not too sure how many of you have a background on VLSI design flow. So I'm like I said, I'm not going to go deeper into kind of defining the overall flow, but just that to kind of give you a high level overview. In the VLSI design flow, there are close to about 18 different domain expertise that you can build your career on. So what I'm going to throw today in front of you is probably about 3 or 4 of them, not all of them. So depending on terms of your appetite or your interest, you could probably have close to about 18 to 24 different domain expertise only in the design space. I'm not even touching upon the opportunities or skills that are good to build on the manufacturing side, because that will probably open up another 50 odd different profiles that you can probably experiment. Net, I see overall about 100 different profiles that you can become experts in. And you can focus purely only on that to start your career. But of course, eventually you can merge, converge, or add other things so that you become much more large scale, so that you will have a wider opportunity. So let me start with something that is called front-end design. Now, front-end design is something that is the starting process in the overall design flow. For example, if I have an idea of a particular hardware or a new processor that I'll have to design, I start with a spec, what that particular product should do, or that particular processor should do. Those specifications that I define becomes the core of that particular hardware. So once I define that, then I give it to the starting point of the design flow is the RTL or front-end design engineer. What he does is basically he tries to take that specifications and he tries to simulate it to run and see whether that probably meets the demand or meets the requirement and things like that, so that there is a reasonable validation of what your idea in terms of practicality is done and validated, so that you don't have to kind of go through the rest of the flow if there are going to be issues that demands you to relook at your spec. Now, let me also highlight why this flow is designed and why it is important that we have to go through this whole step. See, the whole investment from spec to final tape out, right? Or even when fabrication happens, this whole process demands an investment of anywhere between $3 to $4 billion. The design part of it itself is going to take about $1.5 billion. Now, somebody who thinks that if they have a new design coming out, for example, your new smartphone that you're using, unless until they don't find the users are going to buy it and they're not going to utilize it, they don't want to kind of put that efforts or investment to go through the cycle. Now, after you even commit from the business dynamics of it, if you want to still become sure, you run through this whole process where the idea is then kind of validated using simulation, and you use this by building building the whole process through simulation using a software called either HTM, rather VDL, which is called hardware defined language, HDL. But there are different software that we use, System Verilog, VHDLs, and other these software that is going to be used is what is used to kind of validate. Functionally, what it means is essentially is that the hardware that we're trying to design can understand a certain instruction through the language that it can be fed into it, right? That is what we use to create the simulation, and we run it on a simulator to figure out whether the validation of your spec is going to be making sense or not. And that is, this particular career or your domain would require you to become a little better on coding skills. This is not the similar coding skills like a software engineer, but you will be mostly doing a lot of coding using Verilog, System Verilog, or UVM, and run through the EDA tools like Synopsys or Cadence to ensure that whatever validation that you need to do for the spec that has been given is all accurate and correct. But like I said, this particular career demands you to be a little good, or you should enjoy writing coding. So, somebody who has aspiration to be, or they feel comfortable and not worried about too much of complexities of mathematical skills and others, which needs to go in for back-end design, they can probably pursue this particular opportunity. Now, the fundamental question that you might have is there actually an opportunity? Does companies hire? What kind of companies hire? The simple answer for that is it is certainly a very important function on the overall design flow. And every company which is in the design space, fabless design space, need an RTL design engineer or verification engineer, which has everything to do with the front end. So front end primarily means that you take the first part of it after the design spec and try to validate. So that's why it's called front end. So the front actions that you need to go through to ensure that the spec is all proven and it can be done is all done in the initial phase, which is called the front end design. Now, the career path, like I said, is you could become a design engineer, RTL design engineer, or architect, or a verification or a validation engineer as well. So there are going to be multiple flavors of like front end engineer. From as far as I understand, there could be 6 different domain expertise that you can build around the RTL itself, right? So there's going to be enormous amount of opportunities, but the number of people that they hire are not going to be very high, because the number of people who can probably validate the spec. For example, the reason I'm saying is if you build a 300-member design team, you might probably have over 10% of them doing this job. So you probably need to be also aware that whether this job has too many openings that probably will fit in all the kind of skill sets. But like I said, every single company which is into the VLSI design would require this skill sets for sure, right? So these are opportunities that you can build. Let me just do a quick check. I think we are almost in the final leg of the 1 hour, but let me just see whether I can wrap up as quickly as possible. And we will have a follow-up webinar, which will have a little more details in terms of some of these domains a little later, which will be informed on LinkedIn again. So this is only on the high level to kind of give you at least the visibility in terms of what the career opportunities are and whether you will find some value for your career if you commit to this industry. Now, the next one, after you do the validation and the verification of the design, the backend team, which is the physical design, which takes it up and then tries to put that implementation into the design. And this is a lot more complex. And this is where I said your enormous skill sets of putting 20, 30 billion transistors into a real estate or performance, how you need to manage the power performance and the processor performance. All these features are something that you'll have to fix in this particular job role. Very complex, but certainly very exciting and very interesting, because the kind of value contribution that you can make if you become a good design engineer, basically, especially PD engineer, you will probably be fulfilled that you have created some beautiful wonder out of your design. Of course, you can start your career by become a PD engineer, but eventually, as you start building a career, you still don't take up the overall block, but you create sub-blocks or mini sub-blocks, and then you can probably eventually grow as you start scaling up your career. But one of the most exciting aspect of the overall design flow. So again, the tools that we use for this comes from either Synopsys or Cadence. ICC2 is one of the predominantly validated tool that is used for physical design and very challenging to work on as well. Now, even though there are quite a few other domains, but I thought because of lack of time, I'm going to rush through and then complete a couple of slides that I'm left with. Now, what is important that for each of you to become aware is that you cannot be a surface level person. When you think that you want to commit to be in the core industries, you have to become very, very efficient in a specific career domain that you want to build your career with, and become reasonably good at that. So you have to focus on depth, and you cannot be on the surface level, right? I mean, if you think that you want to experiment each of these domains, you want to probably play out in each of these and eventually settle down to one, maybe it not the right advice that I would want to give, because industry does not have time and patience to experiment with people. Unless until you have your friend or a relative who's running a company and they allow you to be experimental, but the industry does not have, because they work on very critical timelines, and each resource that needs to work on, they'll have to ensure that they're all productive and efficient. Because if you ask somebody, if you know anybody from the industry, and if you ask them what is the kind of life that they live during the tape out period, you'll understand the complexity of this industry. That one notion of 1 month or whatever they go through during the tape out is a good example of in terms of what is the kind of crisis you go through and what is the impact you can do for that particular business. Now, one other thing that I see is important, and not many of the engineers, when I speak to them in various colleges, is that not being aware of various tools that are available for you, independent of whether you actually get to work with or rather train at the institute or at your college, is to use a lot of resources that are very, very important for you to become technically visible. GitHub is one thing that I keep hearing that not many have even heard about. Of course, you can't just create an account and sit there idle doing nothing. You'll have to put some projects there, work on something complex. But trust me, doing that and giving that as a reference as part of your resume will have much, much higher chances for you to become employable. So use these resources, work on them, and get to kind of become aware of what's happening in the GitHubs. And there are a lot of people who have posted the projects for you to kind of go and look at it, review it, use it, share it, or modify it. You could find various options to start your experience on GitHub. And I would strongly recommend each of you to go explore that today. And today, I think we are at a fantastic situation where we have the IP for a processor is all open, especially on RISC-V. Unlike in the past when ARM IP was all, even though it was not fully closed, but they could give the IPs to Qualcomm, and that's when they build the mobile processors, and that is where today they have close to about 65% market share on smartphones. But or even earlier to that, Intel had their own ISAs, and they would proprietary use it, and it was not even open as much as even ARM was. But today, I think we have an open ISA from RISC-V, and a country like India are taking advantage of that to build their own processors. And IIT incubator company Incode have built their completely homegrown processor using RISC-V, and it was already started using in space. ISRO is already using it, and defense have started using it as well. So there is a very, very important strategic importance of having our own processor. Of course, I'll cover that in some other session, because it is very important for a country to become more self-reliant by having their own processor and de-risk from any kind of cyber attacks or terrorist attacks, because those other processor from other countries or other technology IP owners is always going to be prone for any kind of a security threat. Anyway, like I said, I'll probably cover that. It needs a lot longer duration to talk about, but that process is open, and anybody is reasonably familiar on the workflow should experiment in designing, building something on RISC-V processor projects as well. And stay connected on IEEE or DAC or VLSI conferences, because that's where you get to see what are the new things that are happening around the VLSI or semiconductor space, so that you probably should be able to start grappling around that concept, building that further from there, and become aware of that, because technology is changing at a pace that probably it is going to be far more unviable for us to keep pace on unless until you connected to any of these platforms. And most importantly, I think I find this as one of the biggest unfortunate situation is a lot of engineers that I meet in both in our campus or even from other colleges. When I see, not many are on LinkedIn. Please understand, for a professional career like yours, the most important platform that you should be spending time to learn, to connect, to socialize is LinkedIn, and not Facebook and Instagram. You might be spending 2 hours or 3 hours on those other social medias, which those companies are making a lot of money, but you're losing out a lot of opportunities to become aware of what's happening, connect to the right people, or not being on LinkedIn. So I strongly urge each of you to become effectively active on LinkedIn, put up your profile, put up the project that you're working on, and hiring companies will look at that very seriously. So I think if somebody is not there, whether you or your friends, I'm sure most of you are aware because you came through LinkedIn. That's where our masterclass was posted. But others, if you think your friends and others are not there, I think it's important that you kind of give them a nudge so that they become active on LinkedIn as well. Now, like I said, there is importance to kind of understand what's happening. I don't know how many of you are even aware of SoC, the system on chip. Um, that's the new technology which allowed us to stack up the chips on multiple layers, and then the complexity of having one chip doing multiple functions was itself was a complex. But today, I think we have kind of moved to the next era of technology like chiplets. If you're not heard of this term or if you're not familiar, I would strongly urge you to go back and do some research. But to summarize what chiplets is, basically it's a different variant of SoC. Instead of stacking them one on another, you could produce them separately on the wafer, but then put them into one single packaging so that they become as one single chip. So there is a lot of commercial value to do that in that format. And also, that gives you a lot of IP control because you're getting that design from multiple vendors and integrate them on one single packaging. So it has multi-dimensional value, hence this technology is getting more popularly utilized. And similarly, 3D ICs are also the future. That probably will drive a lot of the core aspects that I talked about in terms of performance, in terms of packaging, integrating billions of transistors, or bringing in power estimation as well. So that's that's kind of takes Moore's law out of the context itself, because I think things are going to be far beyond what is possible to define Moore's law anymore because of all these new technologies that are coming up. The other thing that is also becoming more and more effective and evident is the EDA tools. EDA, if people are not aware, I'm not, because I didn't ask what is the kind of background of who is attending. So EDA is basically the tool that is used to design the silicon, right? So without that, you obviously can't think about putting 30 billion transistors into a chip, right? So that tool is getting a lot more AI enhancement. Now, what is happening because of that is, what I understand when I attended the Synopsys user group recently was, a tape-out typically takes about 3 years. Today, they claim that it is reduced or shrunk the time to almost 11 months. Now, this, from a business point of view, has a substantial value for getting new chips, taped out, or new products that are coming out, and hence the potential application of that. So it has a much more bigger dynamics on the business side, but from the technology side, is kind of it has, on one side, there's some amount of risk because some part of the validation or some part of the testing is all going to be taken out by the AI tools, but it gives enormous opportunity for the design engineers to churn out a lot of designs, not to worry about some of those complicated mundane process that an engineer does. Those can be taken out, but the design engineer can design much more efficient and better chips in a much lesser time periods with the first cut itself. You don't have to go to multi tape out errors. So that gives enormous amount of economic and technical benefits, and that's going to be the future that I see. The EDA tools are already started implementing it. And I mean, even though I talked about design, semiconductor, there is essentially there is a lot of skills that are still not very actively promoted. The analog, both analog circuit design, analog layer design, yield engineering, all of these will become very, very relevant as we start seeing a lot of fabs coming up, or the packaging units coming up established in India. And we're just in the beginning right now. So going forward, you'll see a lot of these things opening up and building enormous amount of pressure for having the right talent. But don't wait for the industry to set up, because these skills cannot be tuned within each of you in a weeks or in days or months. It needs a lot of commitment. Besides getting trained in an institute, you probably have to work in a real production environment to become a reasonably good design engineer or a manufacturing engineer. So don't wait until the industry set up, but then I think you should commit to kind of building that skill sets from today onwards. Now, quickly to run through in terms of RV skills, like I said, I didn't want to bring that up in the beginning of the webinar. So, like I said, we've been we've been in training, skill development. Earlier it was called RV VLSI. It was incorporated in 2006, and the focus was building the right talent or skills in for the VLSI industry until 2020, 2021, where we saw there's a lot more emerging technologies that we probably have to incorporate. And that's when we kind of changed the name from RV VLSI to RV Skills. RV VLSI is incorporated under RV Skills, performing purely training on VLSI, but we've added up embedded systems, AI, and AE as well. And we'll continue to add other emerging technologies as we start building the right resource and infrastructure on the emerging technologies. But today, I think the kind of impact that we made in the industry is quite phenomenal, especially on the VLSI area. Close to about 6,000 plus professionals have been trained from our industry, and every single company that you can think about will have somebody who must have got trained from RV Skills, and hence they probably find the value of being very reciprocatory, and they hire from us whenever they have a need to hire new resource. They always come back and hire from RV Skills. So that way, it's kind of helping us mutually. One, they also send their engineers to get trained from us. They also hire their new hires from RV VLSI, RV Skills, and for us, we ensure that we keep the value intact, right? And all of this we do primarily because we have created a phenomenal IP training IP using experiential learning. So the environment that we have designed, it's even though we use Synopsys tools for our training, the actual training comes because of the kind of complex design project that we have developed, which our team who have been part of industry for over the last 30 years and understands what happens in industry, they built that over the last 10 years, and they keep upgrading based on new technologies and make it a very interesting learning experience for each of us when they come and join RV Skills. So that is something that I know for sure no other university or training institute have developed that kind of IP, and RV Skills could be one of those who have really invested heavily to build that kind of complex environment where the true learning happens for our engineers. And like I said, most of our faculties are from industry. They've committed to training, so they've disconnected from the corporate world. They've spent all the time here, and we don't run like a commercial organization or multiple badges. We have limited seats. We have limited number because we want to ensure that the value does not compromise. And each of the student who comes here finds the real value of learning so that they become employable in the core industry. And since we've been creating that value for a lot of industries, they come and hire our students. In fact, about 2 weeks back, Intel came and conducted a placement drive. In fact, they don't even go out to the best of the private colleges across India, but they came to RV Skills. 55 of our students were shortlisted for the entrance exam. They conducted the entrance exam in our campus, and eventually they shortlisted about 27. And I think 13 of them have got the offer letters, and the others are waiting in the process to get connected. Similarly, MediaTek and a lot of all large companies come to us, conduct a placement drive. But let me also be very honest, we don't guarantee the placements. It is not the primary purpose of we running this institute. Our primary purpose of running this institute is to give the right skills and placements happen naturally. Okay. So what we do or how different we are is we build a product or the platform where you can learn, apply, and innovate, and not just keep learning based on step approach. So you always learn the concepts and you go ahead and apply them to innovate the learning so that it becomes much more effective. And the learning comes from experimentation, not from theory classes that you probably go through in the colleges. And the exposure is from the real-time industry. In fact, the industry experts come spend time and they give the real industry perspective whenever we conduct industry programs for our students. And the students spend about 75% of the time hands-on, and 25% is where we cover the theory or concepts. Most of it is like hands-on. And there's a continuous assessment, not to rank you, but to kind of ensure that you understand where you stand. And if you need to develop your skills further, you could probably spend more time and correct those scores. So there's a continuous assessment only for you to kind of ensure that you always are ahead of the curve. So that's like, a quick background about RV Skills, and also to kind of give you an insight in terms of where the industry is today, where your opportunity could probably be in the next couple of years, and what is that you need to do. I'm like I said, so because of the lack of time and short time, I will probably not be able to take the Q&A, but you have the email ID listed here, info@rvskills.com. Please do send your queries, or you can call up the numbers are listed so that the team can answer your queries. and I will look at the email personally myself, and we will respond to each of those queries if they come on the email. We will also shortly announce the next level or additional information of what you can probably focus on specific for those skill sets in the next webinar. So kindly do look forward for those details that will be posted on LinkedIn and other social media. So I personally thank you for each of you who have joined us on this webinar. I'm hoping that at least it gave you some indication to understand what is this industry offering and where you probably will be able to build your career and what is that is demanded from you, and to take the right decision to go forward. Thank you very much for each of you joining us on this webinar, and I wish you all the very best. Thank you very much.